Okay, I think
Okay.
I am recording now. So we will try to do that. So let me, I guess, Prasad, I will go over to the, let's talk about the game a little bit. Unless, did I answer, Mohammed, did I answer your question in the chat?
Yeah, I would like to add something to that.
Yeah.
It's depending on the builds, depending on the there are so many things you can do and so many different ways you can score the points. There are easy way to score. There are medium ways to score. There are really high level of complexity needed to score rest of the points. So you really need to understand based on the capabilities of the team expertise, the strength of the team, how many kids are there in the team. You need to select what you can do consistently and what you can do consistently and well. Instead of doing something complex and doing very inconsistently, or it's prone to not score anything and spending a lot of time developing that kind of a mechanism. So start with something which you think, okay, this is the low hanging fruit. We can reach to it. We can develop it. Once we accomplish this goal, we can go for the next one. So set your team targets depending on what you think you can achieve immediately and what's going to take some more time. So spread your team strength and resources accordingly.
Mhm.
So we will go over that over these games, how many different ways we can score,
Yep.
and we'll also walk you through what we think like a easy way to do it,
Yep.
and what will be the challenging one.
Okay, can you guys see my screen? Can you guys see my screen sharing?
Yeah.
Okay. So one of the things that we start off with is like the engineering process, right? Where you kind of first of all like ask, you know, what is the problem? And I think reading the game manual and understanding the game's a big thing. But brainstorming solutions, which is the imagine, right? And plan for what you're going to do, and then actually build a prototype, right? Test it. So we do a lot of testing, that sort of thing, and experiment, right? Go, you know, when you have your field and your parts, you can actually experiment, and then do another iteration, improve on your design. So keep going through this: ask, imagine, plan, create, and improve, and it will help your robot improve, you know, for the next matches. Let me go to the next one. So I mentioned reading these. Okay, so if you read through the game manual, you will actually see different ways to gather points, right? And one is, you know, we mentioned the first 30 seconds is autonomous, then the next minute and a half is driver controlled, and then the last 30 is end game, right? And let me clear all drawings. Somebody drew on the screen. End game points. So there's different ways to actually get points: autonomous, driver, or end game. So has anybody taken a look at this and reviewed it as far as the points? I'm going to talk a little bit more about the different points once I show you the field. So this is the field. Okay, this is where the team stands over here in the blue side, or they stand in the red side. This is actually an in-person game. If you're playing remote, you only have basically the long half of the field. So the two robots have to start on the starting line. And then the first thing they do is, you can see down here, can you guys see that little donut that's on the ground? There's either 0 donuts or we call them rings, sorry. 0 rings, 1 ring, or 4 rings. So in autonomous, your camera would have to detect whether there's no ring, 1 ring, or 4 rings. If there's no ring, you have to bring this wobble over to this square. If there's 1 ring, you have to bring the wobble to this square. Or if there's 4, you have to bring it to this. So your robot would actually have to detect how many rings are actually sitting on the field. So in autonomous, and it would have to do it by itself, right? And then it would have to move this wobble over to that particular ring. So I think that's something that you guys can do. Um, it's programming and it's vision. So, and then taking a look at IntelliOp, which is the driver controlled period, there's actually different things on the sidewall that you can gain points. Let me see what other screen I have. Um, so there's actually the low goal, which is down here at the bottom, and you can score these rings into the low goal. You can actually be on this side of the field. Notice there's a white line in the center of the field. So the robots can actually place it into the bottom. Like if you're a blue robot, you can place it into the blue area. If you're on the red side, you can actually place it into the low goal if you're on this side of the field. Now, if you're a robot that is capable of shooting these, you could shoot them from this side of the line into the mid goal or the high goal. But notice if you're on a blue team, the mid goal is over here on the red side, and then the blue goal is here. So basically a blue team member can get points by putting it in the low or high or blue from this side. Is there any questions on this? You can kind of read more in the game manual. I've got another picture of the, let me see if I can find it here. Yeah, here's the targets here. So you can see the high goal here. There's the low goal, but to shoot a blue mid goal is over on this side. So this one's not, if you're doing a remote event, you're not actually going to have this whole side of the field. So that mid goal won't be, you won't even have access to it. So you can only shoot in the low or the high, or have access to these blue power shot targets. You can knock these power shot targets down depending on what area of the game you're in. Okay, let me go back. There's the wobble goal. You can see it's just about a foot tall. It actually wobbles. It's not too heavy. You said 30 grams per side. I think we picked them up. They're pretty light. So your robot should be able to grab it and pick this up. And your robot should be able to grab and pick these up, these rings. Here again is another picture of the field.
Yeah, it's not 30 grams. The wobble stone is like 0.9 pounds. So about 410 grams. The wobble goal.
Oh, and the ring is 30 grams.
Rings are 30 grams, yeah.
30 grams, okay. So let's talk a little bit about chassis for a second. So I think, Mohammed, you guys are going to be getting the rev kits, that sort of thing. And one of the things Ava mentioned about, in the past we had the expansion hub. This year they're having the new control hub. The advantage of the control hub is it does not require a phone to be on the robot, because the phone and all the Android electronics are within the control hub, and there's no cords that you need. The older expansion hubs, it does require a phone and connections between the phone on the robot and the expansion hub. So I guess, Mohammed, you guys would have to, I'm not sure which one of these you guys will be getting. I think you'll probably be getting the control hub, but that's depending on what you guys ordered. So we can help you. I guess when you guys get the parts, we can help you with that and the strategy in that respect. But one of the things with both of these, whether you have the expansion hub or the control hub, there's a limit on the number of motors and servos that you can have. So one of the things that if you only have one control hub on the robot, we actually have two on ours, but it's a little bit more complicated. But if you have one control hub, we actually recommend to have a two motor drive system on your chassis. So it could either be, like this setup, or it could be like this setup. This is actually a West Coast drive in the middle, I believe you guys will be getting this Rev kit as well, which only comes with 2 Omni wheels, which are in the front. This drive system would require 4 Omni wheels, right? So more than likely, you guys will be setting up your drive system like this, unless you guys ordered extra parts to be able to actually do like a West Coast drive system, right? And for you to build a chassis that actually has 4 motors, you'd actually have to have 2 of these control hubs to be able to drive it, right? It's a little bit more advanced, it's more expensive, but more than likely, this is the drive system that you guys will be using, right? Unless you guys ordered any extra parts. Does anybody have any questions on that? Okay, let me move on. And again, I'm showing a picture of the Rev parts. So, you know, these on the top are all considered Rev motors. I'm not sure what parts you guys will be getting. This one here on the right is a new one that actually has gears in it. We've never used it, but it's my understanding that some of the new kits do have that in there. But more than likely, you will probably have these 2 motors. One's a core hex and one's a traditional motor. And the servos you'll be getting, if you order the Rev kits, will be these servos down here. So basically, your robot can have up to 4 motors and up to 4 servos, okay? Okay, game strategy, right? So we went through a process called RTFD and basically kind of trying to determine how do we get the maximum amount of points. This one's actually just for autonomous. We did one for teleop and we did one for endgame, okay? So we can share this with you, Mohammed. So the way I view is this game this year, we've kind of sat down last night and kind of went through it. There's some really advanced things for advanced teams. And then there's some things that I think basically newer teams, rookie teams can definitely do. But one of the things that I think would be very difficult for a new team would be to shoot the rings almost like a frisbee. And so basically kind of the high goals and some of the power shots, it gets very, very difficult when you start shooting some things. It goes from basically a very simple programming exercise to something very, very, very complicated. And I can show you a few examples as well. So, you know, knocking the power shot targets would be very, very difficult for rookie teams, like with the high or even the low. But one of the things, detecting and deliver the wobble goal in autonomous, I think that's something that you guys can do to detect, you know, the number of rings, take the wobble goal and actually move it to the right place, you know, deliver it. So that's definitely something that you guys could do. You guys can shoot in the lower, definitely the lower is what I'd recommend. So you definitely can do these point systems and then go back and park. You guys can definitely do these last 3, right? To deliver detect the rings, deliver the wobble, you know, drop the rings in the lower. And I'll show you a few examples of what a potential robot may look like to be able to do those sort of things. Okay. So this is teleop, manual drive. The same thing. I'd recommend you guys focus on the low and try to get as many rings as you can in the low, right? And then end game. End game definitely to manipulate the wobble to bring it back to the starting line. And I think the other thing may be to actually drop the wobble over the side of the field. There's actually extra points. This one here over the wall. I think that's something that you guys could be capable of to be able to drop it over the wall. And I'll show you a few examples. So basically looking at this field, shooting in the lower is something I think you guys could do very easily. But when you start going toward these top goals, you basically have to spin them like a frisbee, and it gets really, really difficult. So let me show you some robots that basically a newer team should be able to easily. These are Rev parts here on the top. So again, there's two drive motors here that drive the robot. I'm going to show you this team. This is another team that we worked with last year that's very similar. It has two drive wheels back here. It has two omnis up in the front. I'm just going to show you an example. This robot, all it did was push these blocks from one point to the other. So I'm just showing this example. You guys need to come up with your own designs, but it should be very easy for you guys to take a robot like this that actually has two drive motors and move this wobble around the field, right? You can move this into the different positions, right? Very similar to this, you can push it, right? I'm not trying to design it for you. I'm just giving you a few ideas that some of the new teams, right? I'm pretty sure that you should be able to push this across the field because we looked at that. What do you guys think, Prasad? Should be very easy for teams to. You're on mute.
Yes, yes, it should be very easy for that. But again, this robot is going to only push. That one in autonomous, it won't be able to uh, move this outside the wall in
Right.
end game.
So if you had a robot, this is a rev robot with actually two motors that drive, right? And you guys would have to come up with different, I'm just throwing this as an idea, different design. This robot could push a wobble and it can also pick up a ring. So a robot like this, your teams would need to design some sort of a mechanical grabbing feature to grab these rings. But a robot like this could push a wobble and it can also pick up the rings. And depending on how your end is designed, it may be able to pick up this wobble and actually put it over the edge of the field, right? Which is a 20 point at the end. So I think this type of design, you guys could come up with different iterations of how to pick up. I think it's very capable of you guys picking up a wobble, picking up a ring, delivering the rings in the low, and then delivering the wobble where it needs to go, and even put the wobble over the side of the field. And then you can get 20 points for delivering this wobble. Okay. Um, Keep in mind, I don't know if you notice, I'm just going to point out one thing on the gear up here. It's actually, they've got this motor, rev motor, they've got it geared so that it's strong enough to pick different things up. And maybe something you guys would want to do some engineering calculations on to determine what type of torque is needed for this arm, right? This is a robot here that we designed a few years ago. Actually, you notice it had a bigger gearing on that. You guys would have to do the motor calculations to actually pick up different things depending on their weight. I know Prasad just mentioned it was 3/4 of a pound to pick up the wobble. How much torque would you need to actually pick up the wobble to put it over the side of the field? Here at the bottom, you can see there's some rev parts, different gears that you guys could use in your rev kit to be able to do that, right? So that's something you guys would want to take a look at. This is a picture of one of the clamping arms that we had on one of our first robots called Fred. I'm just showing you a couple examples. This type of gripping feature could very easily pick up one of these rings and put it in the logo, depending on how your arm's designed. Right, here's another picture of it. If you order a kit like this online, you actually have to design it specifically. You have to look at what's allowed and what's not as far as the game rules, right? I'm just showing you a few examples, right, of being able to pick up a ring. Here's another one. This picture is actually dropping an object outside of the field. So imagine if your robot, it wouldn't need this sliding mechanism, but you can actually just have an arm that picks up the wobble and puts it outside of the field. So in the past, we have had robots that have actually placed objects outside of the field. And I think that's something that you guys could do as new teams and get quite a bit of points. Because the robot and the robot alliance can get 20 points each for picking up this wobble and dropping it outside. So I think that's something that you guys can do. Here's a few other pictures of just some basic arms. There's different designs that you could do you guys could design them. These angles, do the engineering calculations of the different arms and the angles. But again, these robots actually have two drive motors on there, have omnis in the front, and then some sort of a arm that picks up things. This is something that I think you guys could do. right? Another picture of another person that they designed a grabbing arm. This could easily pick up a wobble, right? Here's another one, could easily pick up this wobble. Now here's your kits, the rev kits that will be coming in. So you want to take a look at, you know, some of these parts, right? You could use these for arms, you could use these for gears. You've got your 2 drive motors down here. You also have these motors here that actually can power up the arms, right? So there's a good array of parts in here to be able to compete, you know, with your teams. So basically there's 4 ways to score on this wall. I'd recommend that you guys focus on trying to do the first scoring. When you start to get into, you know, this number 2 over here is only in an in-person event. As the remote events, you only have the 1, 3, and 4 ways to score. I'd recommend that you guys focus on the 1. And then these others are actually a little bit more for advanced teams. So I've got a couple videos I'm going to show of advanced teams. Let me pull up the video, kind of show you what I'm saying of these. Let's see. I don't know. Can you guys? You guys can't see my screen, can you? Here, let me see. Let me see. Give me a second. You guys can't see the video, can you?
No, we can't.
Yeah, let's see. Let me see if I can move it over. There we go. Here we go. You guys can see it now, right?
Okay,
Yeah.
now, yeah.
Okay. So this is the high school robot from this last year.
Yes.
And our robots allowed to this year in FTC we can pick up 3 discs. This robot can actually pick up 5 balls, but this is showing you an example of what a more advanced team can do. And this is a high school robot, but you can watch this robot and kind of what it does. Okay, so it had some sort of mechanism to collect the balls and then feed it into a shooter. Shooters are very difficult because they can, like, especially our discs this year are very soft, right? These balls they had a lot of issues with them jamming. Took months and months and months of development to actually get what you see on the screen there. I'm going to show you another picture of it here. Watch this. So I talked earlier about prototyping, testing. You saw the prototyping. I mean, to actually getting into the hole and to shoot these balls took months and months and months of work to actually try to get the shooter tuned in, especially with the soft balls. And our rings are very soft, so it definitely it's an advanced team that would be going to that direction. Here's an example of some of the prototypes that the kids were using when they're prototyping their shooter. Right? So basically these upper goals are going to take a lot of engineering, a lot of testing, especially with this year's game. With new teams, I'd actually recommend that you kind of focus more on the low goal, and then also focus on trying to, at the end of the game and end game, take the wobble and bring it over the side, right? And I think that's something that you guys could do, and definitely start feeding these rings into the low goal. I don't know, Prasad, what do you think? I'm not trying to design it for you, but I'm trying to give you some ideas of where you guys can start.
Yeah, I agree with you. You also have to think that you have only 4 motors you can use.
Right.
So you need to use them wisely. What you can score and how you wanna allocate, how you wanna assign those motors to do what job. You
Right.
can use servos also, but they are not strong and they're slow. And you can use how many? 6 or 12? Six of them on a robot.
Right.
Using one array module. So you can do some of the tasks like picking up the rings, which is a really low weight. You may use a servo for that. But picking up the wobble stone, you may have to use that motor. Wobble goal, you may have to use the motor.
Right. And in the gearing that we talked about as well, right?
That is correct.
Yeah. So do we have anybody online? I know we have a couple other Novi teams. Does anybody else? I see we got Ishan. Got some other Novi teams. Do you guys have any questions about the new game? No, Anik, do you have any questions? I know the. Oh, Ishan and Anik, can you guys hear me?
Yeah.
Yeah, do you guys have any questions? Did you guys watch the game review yesterday? No questions? Oh, come on. There's got to be a lot of questions, right?
Hey, Steve, this is Sandeep.
Yeah.
They had they could not join. They have an overlapping meeting, the Robotitans,
Okay. Okay.
and he just left. Yeah, I think he left his computer on.
Oh, they just left. Okay.
Yeah,
So that's probably why.
yeah, they have they have an overlapping meeting. So
Okay.
yeah.
All right. I think we're probably do we have any questions about motors, or we have some other presentations with motors and servos and that sort of thing, Mohammed, if you guys are interested, but I think that's kind of a good introduction, I guess, for the game that was revealed yesterday. Does anybody else have any questions?
Yeah, I would like to add on this to Muhammad. There are really very small number of teams which are really advanced and can do all. Most of the competitions we go, we see some really low scoring matches. So don't even think about that. Hey, we're gonna just do the basic stuff. If you do the basic stuff and do it consistently, you can win a lot of matches. So just I would suggest go for easy high points in terms of autonomous and end games. In teleop, we know that you have to continuously keep on shooting or delivering for 1 minute 30 seconds, but the scoring is really low if you are going for low goals and all other things. So strategy is going to be the key. How are you gonna assign these 4 motors? And especially 2 of them are like 125 RPM, right? Those core hex motors.
Go back to the screen.
Yeah, they are not as strong and as powerful as regular motors. So you need to definitely look at the specs, what you will need.
These motors here, right? So
Yeah.
So see the core hex, right? The speed and the torque of it. I mean, it's a nice motor. It's flexible from a geometry perspective, but it's not high torque or high speed, right? So
Especially for picking up the wobble stone and moving, right? If you see the torque from this Rev core hex motor is good, you don't have to worry much about RPM because you're gonna do just maybe 270 degrees or 180 degrees of rotation.
yeah,
It's not, you don't need a continuous rotation of that. So you don't have to worry about speed for that. You have to worry about torque.
correct. Okay. And I think, part of the reason why I don't think we have a lot of questions is a little bit with the language barrier. So So I wish I knew 5 different languages where I could. So hopefully the other teams this was helpful for you, and despite the language barrier. But I appreciate everybody for calling in. If we don't have any other questions, I think we'll just kind of end the call. Does anybody else have anything?
Yeah, I'd just like to add on, Mohammed, that we'll be there anytime you need us. So feel free anytime to contact us. Any specific questions, anything on programming, we'll work with you, and we'll make sure that you'll have a successful year.
Yep.
I have a question.
Yeah.
So are we still going to have our meeting at 4 o'clock?
Not today.
Oh,
Yep.
okay.
Yeah, not today.
No. Well, I think we're going to have one Wednesday. I think is the next meeting.
Wednesday at what time?
Yeah, I'll send it out in the chat.
Okay.
So anybody else have any other questions? I think that's it then. Everybody have a great day, and thanks for the team that joined us. Thanks. See, the Wizards are on. It's great hearing from you
Okay,
guys.
so there is one more coming from Alice. He wanted to get some email address and see if there is any other way, like a Discord, where we can communicate.
I have the email addresses for the team. So
Yeah, and we can always arrange for Zoom meetings whenever you guys need it. So let us know.
yeah, I think it may. Looks like we have somebody else joining here. And maybe we can get somebody to help us a little bit with translation. If one of you guys has a friend that's fluent in Arabic, they can help us as well. So, well, thank you everybody for joining. Hopefully this was helpful, and we will talk to you later. I don't think there's any other chats, is there? I don't believe
Yeah,
so.
and you can just email it to us, like anything you need help. We
Right.
can send email it back to you. After that, if you still need to communicate or meet, we can go for meetings. Okay.
All right. Yeah, we got a couple chats. Yep. All right. Thank you, Wizards.
you.
All right. We wish you guys good luck this season.
Yeah, this is a really interesting game. It's going to be fun to play.
Yep. It's good talking to you. All right. Everybody take care. All right.
Bye.
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 Bye. Bye.